In this video, we are going to start thinking about different forces to understand how interactions at an atomic level take place. Let's start our discussion with a look at the model of the atom we are going to use for now. Throughout this discussion, remember that atoms are electrically neutral. As you see in the image here, at the center of the atom we have the nucleus, which takes up a very tiny amount of space. The nucleus is composed of protons and neutrons, while the electrons are found in the cloud surrounding the nucleus, which takes up most of the space of the atom. We will discuss why we refer to it as the cloud of electrons later. The protons have a charge of +1 and a mass of 1 atomic mass unit, or AMU. The neutrons do not have any charge and also have a mass of 1 AMU. The electrons have a charge of -1, but the mass of an electron is very small compared to that of a proton or a neutron. It is about 1/3000th the mass of a proton or a neutron, so most of the mass of an atom is concentrated at the nucleus. The model of the atom we discussed presents us with some interesting questions. First, consider the positively charged protons concentrated in the nucleus. Why don't they repel one another? Second, since the electrons and the protons attract each other, why don't the electrons fall into the nucleus? And finally, do the electrons within the atom repel each other? The way that atoms interact is a central concept to chemistry. To understand how atoms interact, we will use the idea that positive and negative charges attract and like charges repel. This notion that opposite charges attract and like charges repel is known as Coulomb's law, and we'll come back to this later. However, before we look at the specific atom interactions, we need to discuss the concept of force. What is force? We usually define force as a push or a pull. Remember that atoms don't actually touch one another, and that each push or pull happens over a very small distance. Imagine pushing two magnets together. Opposite charges will be attracted to one another, while like charges will repel one another. In chemistry, you will hear the word interaction as another word for force. An interaction is a force between two separate species that can occur over very small distances. When you think of a force, you may consider electrostatic forces such as lightning, or magnetism, or maybe even gravity. Every push or pull can be explained in the context of four fundamental types of forces. These are gravity, electromagnetic force, strong nuclear force, and weak nuclear force. Strong and weak nuclear forces work to hold the nucleus together. We won't worry much about these until later. For now, let's focus on gravity and electromagnetism. Gravity is responsible for attraction between objects that have mass, while electromagnetic force is responsible for attraction and repulsion between objects that have electrical charge. You are probably most familiar with gravity, but chemists care most about the electromagnetic force, since most chemical interactions are due to the electromagnetic force. Let's take a moment to do a concept check. Here is Katie. She has thrown a ball into the air. What forces are acting on the ball? After the ball leaves her hand, the only force acting upon the ball is gravity. Gravity can act over a large distance. There are no electromagnetic forces, as we do not have charged objects in this example. Check out the gravity simulation linked with these slides for a more interactive look at gravity. The relationship between mass, distance, and the force of gravity is known as Newton's Law of Universal Gravitation. It can be modeled by the equation shown here. Notice how you cannot have a negative mass or distance, so the gravitational forces are always going to be positive. Also notice how gravity will decrease as r, the distance between two objects, increases. Also, please notice that this is a simplified version of this equation, shown to highlight the relationship between mass and distance. With all this in mind, How do you think the gravitational force of the Earth is able to influence the ball even though the ball and the Earth are not in contact? You can check out the other videos provided along with this one to explore these ideas further, especially Newton's Law of Universal Gravitation, which tells us what happens but doesn't really explain why. So, how does gravity actually work? The idea is that objects with mass are sources of gravitational fields. Here, you see a representation of the gravitational field of the Earth and the Moon. The gravitational fields interact with all other objects with mass and energy. The idea here is that you need to have two objects to observe gravity. And this is partly why gravitational forces are always attractive.